Monitoring an operational network can provide a network administrator with information to proactively manage the network and to report network usage statistics to others. Link activity error rates and link status are just some of the few of the factors that help a network administrator determine the health and usage of a network. Collecting and reviewing this information over time enables a network administrator to see and project growth, and maybe enable the administrator to even detect and replace a failing part before it completely fails. In this chapter, we look at three protocols that a network administrator can use to monitor the network. There's Syslog, SNMP, and NetFlow, which are three popular protocols with each having their own different strengths and weaknesses. But together they provide a good tool set for understanding what is happening on a network. The network time protocol (NTP) is also used to synchronize timing across devices, which is particularly important when you're trying to compare log files from different devices. Okay, so there are three basic things that we will look at in this first part of the video. I will just talk about Syslog operation in a small to medium size business network, and then the later videos we will look at SNMP and also configuring SNMP and looking at NetFlow as well. So after every video covering the topic, at the end of that there's a short review quiz for you to do to summarize by way of summarizing what has been discussed in the lesson. Okay, so the first section 8.1 we'll look at Syslog. Syslog is a very important protocol or technology, and it's a term that is used to describe a standard. In other words, it's also used to describe a protocol developed for that particular standard itself. So the first of all, the Syslog protocol was developed for Unix systems in the 1980s, but was first documented in I believe in the RFC 3164 by IATF in around 2001. And then what's really important about Syslog is that when certain events occur on a network, networking devices have some form of trusted mechanisms in place to notify the administrator with detailed system messages. Thus the word syslog. In short, this basically means system login or system logs. So these messages can be either non-critical, not just information, or they can be significant critical information. Network administrators have a variety of options for storing, interpreting and displaying these messages, and for being alerted to those messages that could have a great impact on the network infrastructure. So the most common method of accessing system messages is through the use of Syslog. Again, Syslog is a very interesting standard, and it's a very interesting protocol. Syslog uses UDP port 514 to send event notification messages basically across IP networks to event message collectors. And as you can see here, there are three key things that you will be looking at when you're trying to implement Syslog. First of all, this is what we will be interested in, the messages. But then we need to have a way in which we could collect those messages. So you have the Syslog messages, which typically come from routers and switches. Those Syslog messages need to be captured, and Syslog server is where you need those messages basically to be captured. So I said three, but it's in fact I just talked about two. So it's two critical components. We need the syslog server, and then we need a way in which by we could capture the type of messages we are interested in. And of course, with the syslog login service, there are three primary functions that are provided here. Take note that many networking devices, they support syslog, so it can be the routers, switches, they can be application servers, firewalls, even other network appliances. Syslog is typically supported by any networking device. So this syslog protocol, it allows these devices, networking devices, to send all these messages, system messages, across the network to the servers. So it's possible to build a special out-of-band network for this purpose. What this basically means is this out-of-band network in place is just purposely for collecting system messages, and there are various ways in which this can be done for a number of purposes, but syslog login service provides three primary functions. Number one, the ability to get a login information for monitoring and troubleshooting, the ability to select the type of login information that is captured. So number one, gathering login information. Number two, selecting the type of information or login information. And number three, specifying the destinations of captured syslog messages. So we would want to gather information here. That's number one. But we have to specify the type of messages we're going to capture. And number three, we need to have the ability to also specify where, in what destination are we going to capture those syslog messages. So these are three important functions of syslog servers. Now let's have a look at syslog operation a bit more in detail. On Cisco networking devices, the syslog protocol starts by sending messages and debug output to a local login process that is internal to the device, meaning to say that each particular device has its way of capturing messages. So every Cisco networking device has its own local login process that is just internal to that particular device only. Now let's say, for example, we have this server terminal line whereby we have a switch whereby it captures some system messages, which typically when you go show run or show debug, they show up. These are messages that are captured by a login process that's internal to the device alone. Now how the login process manages these messages and outputs is based on the device configuration. And if, for example, the syslog message is to be captured on a external syslog server, then that message needs to be sent, for instance, from the switch to the syslog server, so that that message can be viewed from the syslog server instead of from the command interface right in the switch. So this is where we are now looking at popular destinations where syslog messages can be captured or can be stored. So log messages and outputs there, when they're stored on an external server, they can then be pulled into various reports for analysis purpose or for easier reading. So alternatively, syslog messages may even be sent to an internal login buffer. Now messages sent to the internal buffer are only viewable through the command line of the device, and that's typically what we would normally do if we wanted to do some debugging on a router or on a switch. That's typically the option that we would go for. Now A network administrator might specify that only certain types of system messages are sent to various destinations. For example, the device may be configured to forward all system messages to an external syslog server. Let's say this switch is to send all messages to the syslog server. However, debug level messages can be forwarded to the internal buffer only accessible by the administrator direct from the command line. So you can see here that there are at least a number of destinations for syslog messages. Could be the login buffer, which typically is the RAM inside the router or a switch, console LAN, even terminal LANs, or even via syslog servers. It is always possible to remotely monitor system messages by either viewing the logs on a syslog server or by accessing the device through telnet, SSH, or even through the console port itself. Now, with the syslog messages, the best way to see this is knowing that each syslog message falls into a number of levels, and like we saw earlier on, syslog messages can be either just non-critical, or they can be significant messages that need to be attended to. Say, for example, emergency type of messages. So this is where those meanings come in. The syslog levels come in. They have with their own meanings. For instance, warning level to say emergency level. These messages from emergency to warning to emergency level. These are critical messages. They are very critical messages, and these are typically error messages about software or hardware malfunctions. And this type of messages will mean that the functionality of the device is going to be affected or has been affected. So the severity is going to be a low number. So the severity of the issue determines the actual syslog level that is applied. So you see, emergency has a severity level of 0. So anytime you see a syslog message with a severity level of 0, that's an emergency. Anything from 0 to 4 is critical. It's going to affect the functionality of the device. So remember that syslog severity levels from 0 to 4 are emergency to warning. These are levels, messages that need to be attended to ASAP. Now, on the other hand, there are debugging level messages, which are the highest level, level 7. These are just indicating that messages output generated are from debug commands. And then, of course, there's informational and notification messages. These are just only for information. Most cases, well, no device functionality is typically not affected by this type of level of messages. Syslog facilities are service identifiers. That's a key thing that you need to take note of here. They identify and categorize system state data for error and event message reporting. So the login facility options that are available basically specific to the networking device, and they vary from device to device, and of course the type of iOS it supports. But some common syslog message facilities reported on iOS routers, they will typically include the IP, the OSPF protocol, the sys operating system, IP security interface, and firewall. These are some of the things that might be reported. With the syslog, continuing on syslog operation, another important aspect of log messages is for them to have a form of timing, okay? A timestamp. In other words, a timestamp is very important. So log messages, they can be timestamped, and the source address of a syslog message can be also sent along together with the message itself. And this enhances real-time debugging, and for ease of management, when you're troubleshooting, you would want to know at what time on what date particular events occurred or situations arose that needs attention. So when the service timestamps log uptime, the log uptime command global config mode is entered, command is entered, the amount of time since the switch has been booted is displayed on logged events. And a more useful version of this command is the one given here. Service timestamps log and date time. So instead of in place of the keyword uptime, you now have date time instead. So you could either have service timestamps log uptime or date time. So this command basically forces each logged event to display the date and the time associated with the event. Now when using the date time keyword, the clock on the networking device must be set. If the clock is not set, the system cannot record the timing. So this can be accomplished in one of two ways. You either manually set the time using the clock set command, or you could automatically set using NTP. Now recall that NTP is a protocol that is used to allow network devices to synchronize their time settings with an NTP server. So really this relies and basically on an NTP server that's going to give the timing, which is really important in this case because the timing given by the NTP server has to be consistent across all the devices within the network. So it allows all the software clocks to be synchronized by the NTP server. So the command to do that is to use NTP server, and then you specify which particular router or device, NTP device, is going to serve as your NTP server. So in this diagram, in this figure here, you can see we have router 1 as a client, and on this network we have router 2 acting as an NTP server with this IP address. So here we specifying using the NTP master 1, we specify which device here are we going to set as the key the key NTP server. Like there can be a number of servers, and one thing we have to take note of is whenever we specify an NTP master 1, that device or that router now serves as an authoritative NTP server, and this allows or it can be configured as either an NTP server or well as an NTP server, and it allows to synchronize all the devices that pointing towards it as its timing tool. So very important aspect in a system where you would expect to log messages. So if we're going to use Syslog, NTP is very important, as well as the other two protocols. They rely on NTP for information. Okay, so Syslog servers, the advantage about Syslog servers is they provide relatively user-friendly interface. So you're taking that command notifications into a GUI interface where it can be viewed and analyzed for reporting purposes. So what the server does, the server analyzes the output, places the messages into predefined columns. That makes it very easy to interpret, and if the timestamps are configured, the more better. So you can tell the date and the time when each message, each event has occurred for troubleshooting purpose. So this allows network administrators to easily navigate sometimes large amounts of data that can be compiled on a Syslog server. It can be a very difficult task, but Syslog and NTP makes it quite easy to do the troubleshooting work. So by default, Cisco routers and switches, they send log messages for all severity levels to the console by default. On some iOS versions, the device also buffers the log messages by default. So if we are to enable these two settings, the two commands that will allow for this to happen, the login console command and the login buffered global config commands. Using these two commands will allow us to set either messages to be sent to console or to the buffer log. And if we wanted to display the default login service settings, show login should help us to achieve that. So here in this diagram, in this image, you can see an example here. The show login command has been used, and it displays the default login service settings on this particular router. In this case, notice that the first highlighted line here, okay, we have at least three. The first line you can see here, console login level debugging 32 messages logged. It states that this router logs to the console. That's the first information, console login, and it includes debug messages, so level debugging. And this actually means that all debug level messages, as well as any lower level messages such as notification level messages, are all logged to the console. On most Cisco iOS routers, the default severity level is 7, which is debugging, and the output also knows that 32 messages here have been logged already. Now the second line highlighted states that this router logs to an internal buffer with the first word buffer login, and because this router has enabled login to an internal buffer, the show login command also lists the messages in that buffer. So you can see at least a number of messages that have been captured in the buffer right at the end of the output. Okay, so two ways. By default, they can either go straight to console or even to buffer, so depending on the iOS. So these are the two commands, the login console and login buffered, if you're going to enable those two settings. So to login console, to allow for console login, login buffer, to allow for output messages to be sent to be buffered. In the next video, in one of the videos, we'll try to look at configuring route and switch commands for Syslog clients. At this point, I'd like you to look at the quiz activity and see if you can identify, just by looking at the entry, the Syslog message, see if you can identify each of those sections. What does each of the sections mean? I'll give you an example. See if we can find a message here. Oh, yep. There's nothing shown here. If you go to the activity part 1 and part 2, there are at least two different logged messages that have been captured. Now your task is to identify if you can see each of the sections, the severity level, the mnemonic number, description of the message, and so on and so forth. There are different sections to it.